Hi students, welcome you all for the session of water treatment process. In this session, we'll be going to discuss Module 3, a topic on sedimentation. So the outline of the session will be theory of sedimentation, settling types, and the settling tanks and its types. Now as the raw water, which comes from the screening part, contains number of suspended impurities or particles. Such suspended particles can be removed effectively by allowing the particle to settle down in a water for a known time. This process of removal of suspended particles by gravitational settling under the still water condition is called as the sedimentation. The objectives of sedimentation is to separate the suspended solids from the liquid using the force of gravity. And the basin in which the flow of water is retarded is called as the settling tank or the sedimentation tank, or also it may be called as the sedimentation basin or a clarifier. And the theoretical average time for which the water is detained in the tank is called as the detention period. And the tank which has been designed, it has to be designed in such a way as to reduce the flow of velocity so that to permit the suspended solids to settle out by the action of the gravity. Now this sedimentation process can be used in the various parts, maybe in the removal of the grit in the grit chamber, or maybe in the particulate matter in the primary settlings or in the secondary settling basins, or also in the destabilized floc in the clarifoculators, or removal of the biological floc in activated sludge, removal of the solid concentrations in the secondary settling tanks. Now coming to the types of sedimentation, there are two types of sedimentation, namely plain sedimentation and sedimentation with coagulation. In plain sedimentation, impurities are removed by the action of gravity alone. So the water will be allowed to stay in the still water condition where because of the gravity action, the impurities will be removed out. It is simple and cheaper method and it is used in the filtration of water technique. And the second type of sedimentation is sedimentation with coagulation, where the impurities are removed by inducing the chemicals in water, forming the flux. Then with the rapid mixing of water, which coagulates and forms the flux, and those flux will be removed by the process of sedimentation. So in detail, we will be studying both the types, that is plain sedimentation and sedimentation with coagulation. Before studying the types of sedimentation, we should know the types of settling of the particles, how the particles actually settle down. So settling of particles mainly depends upon the characteristics of particles and concentration of particles in suspension. So according to the characteristics and concentration, there are four types of settlings are possible. They are discrete particles, flocculating particles, hindered or zone settling, and the compression settling. Now coming to the first one, that is the discrete particles. Particles settles individually without the interaction with the neighbor particles. The size, shape and specific gravity do not change with the time. So if we see in this diagram, so this picture indicates the type of discrete particles, discrete settling. Okay. So each particle, because of their own weight, they will settle down. Okay. They don't need any external force to be settled down because of their own weight. Since the particles are individual here, they settle down easily. So such type of settling we call it as discrete particles settling. Then the second one is the flocculating particles, where the flocculation causes the particles to increase in the mass and settle at the faster rate. So because of this, there will be the change in size, shape, and also the specific gravity with each contact. So here you can see, so the particles are getting attracted and which will be formed as the flock. And this flock, once it forms changes into a bigger size, then it will start settling down. So such type of settling, we call it as the flocculent settling. And the third type is the hindered or zone settling. Here, the mass of particles tends to settle as a unit with the individual particles remaining in fixed position with respect to each other. So in this case, each particle acts as a individual unit. So this individual unit, they settles down without hindering or without causing any harm to the other particles. Then the fourth type of settling is the compression settling. The concentration of particles is so high that sedimentation can occur only through the compaction of structure. So because of the concentration of particles, so if you see in this picture, because of the concentration of high particles, they compact each other in such a way that they need some external pressure to settle down. Okay. So such type of settling, we call it as the compression settling. Some of the examples of the settlings are, for example, the discrete settling can be applicable for the removal of the grit or the sand in the wastewater treatment, and the removal of the suspended solids in the secondary clarifier comes under the flocculate settlings, whereas the removal of the biological flock wherein the wastewater treatment which comes under the secondary treatment, they come under the hinder settling, and whatever the sludge which gets at the bottom of the tank is comes under the compression settling. Next here is we'll be going to discuss types of sedimentation tanks. Sedimentation tanks may function either intermittently or continuously. The intermittent tanks, which are also called as the quiescent tanks, are those which store the waters for the certain periods and keep it in complete rest. Whereas in the continuous flow type tank, the flow velocity is only reduced and water is not brought to the complete rest as what we do in intermittent tank. So usually we go with the continuous type of tank, because in the intermittent tank we have to allow the water for the complete rest, whereas in the continuous only the velocity will be reduced, so the flow will be continuous. So according to the shapes, there are three types of the setting tanks, that is rectangular tank, circular tank, and the third one is called as the hopper bottom tank or the vertical tank. And usually the rectangular tanks with the horizontal flow are generally preferred with compared to the circular tanks or hopper bottom tanks. Now coming to the rectangular tank, these are the long rectangular basins which are hydraulically more stable and flow control for the larger volumes, which is easier because of the configuration. A typical long rectangular tank have a length ranging from 2 to 4 times their width, and their bottom is slightly sloped to facilitate the sludge scraping. A slow-moving mechanical sludge scraper continuously pulls the settled material into the sludge hopper, from where it is pumped out periodically drag of the sedimentation tank. So in the figure, if you see here, so this is the sketch of a long rectangular tank. From here the water will be inletted, influent. So this is called as the baffle wall. So the function of the baffle wall is to reduce the velocity. Okay, in order to reduce the velocity, these baffle walls will be used. Okay, so they will reduce the velocity and also hinder the turbulence of the water. So at this portion, the sedimentation takes place. So the portion for which the water is placed, it is called as the water depth. At the bottom, the sludge will be collected, and this is the mechanical arrangement of the sludge scraper. So using this scrapers, the sludge will be collected here down at the sludge hopper, and it will be taken out. And whatever the suspended water or the sedimented water will be collected through the effluent weirs, and it will be sent to the next section. So this will be the total depth of the tank, which includes the freeboard, water depth, and the sludge depth. Now, coming to the advantages, it is a continuous flow in tank. There will be a continuous flow, and as the construction is cheaper and maintenance is easy, supervision and labor work is less. Easy maintenance as the tanks are arranged in series. Because of continuous flow in the tank, time waste rate will be lesser. Now, second type of tank is the circular tank. Circular settling basins have the same functional zones as the long rectangular basins, but the flow regime is different. When the flow enters at the center and is baffled to flow radially towards the perimeter, the horizontal velocity of water is continuously decreasing as the distance from the center increases. Thus, the vertical path in a circular basin is a parabola as opposed to the straight line path in the long rectangular tank. Sludge removal mechanism in circular tank are simple and requires less maintenance. Advantages are easily sludge removal, high clarification efficiency, and for the plants with the constant flow and quality, this type of sediment basin is more suitable. So this is the picture of the circular basin. So what happens is, now here the raw water will be taken from the bottom and at the centrally it will be taken inside. And from this portion, the water will be allowed to flow on both the sides of the tank. Now since the path is not a straight path here, it is like a parabolic path. So the sedimentation will be effective in the circular tank. Because of the path, the particles will settle down easily. Okay, in circular type of sedimentation, the path will be like in a parabolic curve, parabolic direction. So due to that parabolic direction, the settling will be easier. And the sludge removal, again, it will be done by the sludge arrangement, sludge scraper, which is a simple and can be easily driven. Sludge can be easily driven. Now, and the whatever the suspended water or the treated water will be taken through this effluent weir and it will be sent to the next operation. So because of the radial flow, the velocity will be decreased continuously as the water passes from the central direction to the periphery. Okay, so at this periphery, at the sides of the tank, the velocity will be very lesser so that the particles will settle effectively. Now in the path only, there are two types of circular flows. One is the radial flow and another is the spiral flow. In radial flow, the water enters in the tank through the centrally pipe placed. So here if you see in this diagram, the water enters through the central pipe. Circular baffles are provided to reduce the velocities and impurities are collected at the bottom which are removed by the sludge scrapers. So in the radial flow, the water enters through the central inlet and it will be passed on both the sides of the tank in the radial manner. Okay. Whereas in the spiral flow, the water enters the vertical slit. Here the raker's arm are provided with the blades which allows the water to move along the circumference of the tank. The water moving at very low velocity allows the suspended impurities to settle in the tank which can be removed out from the sludge outlet. So in this type, the water influent will be taken from the central, but the flow will be the spiral. Okay, spiral in the sense in the shape of a spring. So what will happen is again the velocity will be The third type of the sedimentation tank is hopper bottom tanks, or also we can call it as the vertical tank. The shape of the base of the tank is like a hopper type, and these are the vertical flow tanks because water flows upwards and downwards in these tanks. The water enters in the tank from the top inlet channel, and because of the deflector box which is placed inside the tank, it allows the water to flow from upper to lower. Because of this, the impurities settles at the bottom of the tank, and the pure water or the treated water will be taken by the draw-off channel. And the sludge outlet pipe is used to remove the sludge from the tank. The detention period varies from 3 to 4 hours. So in this picture you can see the water will be taken inside from this pipe or from this arrangement, and this deflector box whatever placed here, they allow the water to move in a vertical manner. Okay, because of the movement in the reverse direction, the particles will start settling down. Okay, as the particles are of the having the more weight than the that of the water particles, the particles will start settling down, and this water will be taken through the outlets. So here the flow of water will be in a vertical manner, so hence we can call this type of tank as the vertical flow tank or hopper bottom tanks. Now the long rectangular zones or the circular basins, the basins are divided into 4 zones. Okay, where the water is allowed for the sedimentation, that zone will be divided into 4 zones such as the inlet zone, settling zone, outlet zone and sludge zone. So in this picture, if I show you, so you can see here, this is a rectangular tank where it is totally divided into 4 parts as inlet zone, settling zone and outlet zone and the sludge zone. And coming to the circular tank, here where the water will be taken inside is the inlet zone, and this portion is the settling zone, and this is the outlet zone, and at the bottom it will be a sludge zone. Now inlet zone is a region in which the flow is uniformly distributed over the cross section such that the flow through settling zones follows the horizontal path. For this, the baffle walls are used, that is for the smooth transition of the flow. So whatever the water is influented from this inlet, in this zone, these are the baffle walls having the pores with them. So this wall reduces the velocity of the flow and they allow the flow for the smooth transition from the turbulent to the horizontal path. Then in the settling zone, which is the largest area of the basin where settling occurs under the quiescent conditions. So water will be allowed to for reduced, or its velocity will be reduced to a greater extent such that it will be in a rest condition. Then whatever the clarified or treated effluent is collected and discharged through the outlet weir, which comes under the outlet zone. So this zone also controls the depth of water in the basin. So here also a baffle wall will be provided and the weir will be provided for the transferring of the effluent water to the next operation. So it controls this baffle wall controls the depth of water in the settling zone. Then coming to the last zone, that is the sludge zone, where the collection of the sludge will be taken place, which is below the settling zone. Okay, and this sludge will be removed through the sludge scraper through the sludge outlet. So these are the 4 zones where the settling takes place. Now coming to the arrangements which are made at the inlet of the tank and outlet of the tank, At the inlet arrangements, the inlets are designed to distribute the water equally at the uniform velocities. A baffle wall should be constructed across the basin close to the inlet and should be project several feet below the water surface to dissipate the inlet velocities and provide uniform flow. So at the inlet of the tank, that is where the inlet pipe is provided, in order to get the uniform velocity, the baffle walls are provided. So this is one type of the inlet device where the baffle wall is provided here up to a certain depth. So at this area, the whatever water is coming at the certain velocities will be transferring into a smooth flow. Oh, so they will be rendering a smooth flow of a water. So these are again some types of the inlet arrangements. So here also baffle walls are made with the multiple openings. Multiple openings are made in the baffle wall. So this is also one time of a openings where here in this portion whatever the turbulence is there, it will be reduced to a, that is the velocity will be reduced to a greater extent. Now coming to the outlet device, the outlet weirs or the submerged orifices shall be designed to maintain the velocities suitable for the settling in basin and to minimize the short circuiting. So whatever the effluent coming from the sedimentation tank has to be taken out very with the uniform velocity. So in order to get the or in order to maintain the uniform velocity, the weirs or a orifices are used. Okay, so in order to minimize the short circuiting. So in this picture, what you are seeing here, the rectangular small weirs are used from where the effluent will be taken out and it will be passed to the outlet. So again here the baffle walls which allow the water for a uniform velocity. And here also orifices are used, or these are sorry, weirs are used of the crested type. Okay, so here whatever the water present in the tank which will be taken out to the effluents. So here in order to maintain the velocity, we have to use the weirs or the orifices. So these are the some outlet arrangements and some inlet arrangements. So in today's session we discussed about what is sedimentation, what is sedimentation tank, what are types of sedimentation, what are types of settlings, then what are the types of sedimentation tanks, what are the various zones in the sedimentation, and inlet and outlet devices. I hope you understood the topic. In our next session, we'll be studying the theory of plain sedimentation. Thank you.